Hello, Sir Michael Pabustan. My name is Gabriel Emmanuel Brito, and I'm here to report Airframe System Lecture, Section 15114, and I am taking BS Aircraft Maintenance Technology, second year student, and the topic I chose is the methods and system of ice and rain protection. So, in this topic, we will examine the methods used to detect when an aircraft is flying in icing condition, and we will look the various systems that can be used in the aircraft to prevent ice and rain becoming a problem in the aircraft. So, here we will first quickly look at how ice form, and then we will look at the various systems that can be used to detect icing condition and gives a warning to the pilot. Let me explain how icing buildup in the aircraft. Icing buildup in the flight is caused of the water droplets that is supercooled in the atmosphere. This buildup may affect the aerodynamic properties of the aircraft. There are two types detector that can sense buildup of ice. One is the accretion type system, and another one is sensed by measuring temperature and humidity when icing conditions are present. These are known as inferential type system. And here is the simplest type detector that is the pilot's eye. Because using your eyes, you may be able to see ice beginning to build up on such thing as leading edges of the windscreen wipers. And some aircraft may have light to eliminate the wing and fin leading edges plus the engine intakes to help the pilot to monitor for the buildup of the ice at night. On some aircraft have pilot's eye is only the eye detection system. Then for assisting the pilot, some aircraft have a device known as Eddington ice detector. This detector consists on a airfoil shape mass protruding into the airflow, which is visible to the cockpit. The mass incorporates a heater element, and a light to illuminate the mass at night when icing conditions are encountered in flight. With the heater power supply switch off, accumulates on the mass and gives a direct visual indication of of ice indication of ice accretion to the heater. The heater may be switched on for a short period to dissipate accumulated ice. The more quickly the ice reform, the more severe of the icing condition. Then here is the Smith ice detector. Smith ice detector is another accretion type of detector. It consists of a hollow tube attached to the aircraft by one end sitting in the airflow, and it has a hole drilled in the leading and trailing faces. There are 4 holes in the leading edge and 2 in the trailing edge. In flight under normal condition, the air enters the 4 front holes more quickly than it connects it by the rear, and this causes a pressure buildup in the tube, which is sensed by a capsule connected to its base. The capsule expands, keeping a pair of electrical contacts apart in icing condition. the leading edge holes become blocked by ice and pressure in the tube falls the capsule contracts causing the ice warning light. To eliminate there is a heater element fitted around to the tube to melt accumulated ice once again. Then icing. The more quickly the ice reform, the more severe are the icing condition in the English electric or Napier ice detector. Is a mechanically operated and Chretine type of detector. In this detector, serrated rotor shaft is continuously driven by an electric motor. The shaft rotates adjacent to fix a knife edge cutter for the clearance between them of a less than 2,000 of an inch. The unit is mounted on flexible mountings. On the side of the aircraft is the fuselage with the rotor shaft protruding into the airflow with the axis at the right angles. To the airflow, the cutter is in alley of the shaft under normal conditions. Little torque is required to drive the rotor in the ice conditions. Ice buildup on the motor is shaved off by the cutter. Shaving off of the ice requires greater rotational torque and causes the motor to rotate slightly in its flexible mountings. This movement operates a micro switch which gives a nice warning. Then the warning remains as long as ice continues to foul the cutter. Blade. The Rosemount ice detector is another mechanically operated accretion type of detector. It consists of a short cylindrical probe positioned in the airflow, mounted on a vibrator housing which vibrates the probe. Axially, if I spill up on the probe, the added mass reduces the frequency of vibration. When the frequency falls to a predetermined level, an ice warning is given. When the ice warning is given, na built-in heat elements and hits the probe, which mount the accumulated ice, allowing the vibrating frequency to return to normal and the warning to stop after 6 seconds. The heater switch off and the icing ciliary commence. Frequency of the cycle may be measured to give an indication of the ice accretion. The final accretion type of ice detector that we want to look at this is beta particle detector. This is the most modern type of detector. It has no moving parts. The detector consists of two probes mounted perpendicularly from the forward fuselage. The forward probe is an emitter which emits beta particles. The rear probe is a beta particle detector which detects the level of particle transmission. From the front probe, beta particles are absorbed by ice on the icing condition. Fewer particles are sensed by the detector at a certain beta particles count rate corresponding to approximately 0.4 millimeters of ice. A relay in the detector probe will be causing a warning in the flight deck. Ice can only be formed when there is a combination of moisture and freezing temperature. Then in the Sangano West Rise detector, These two conditions detected separately and therefore icing condition are detected rather than actual ice formation. This is an inferential type of ice detector. The system comprised the three main components. Moisture sensing head of moisturized detector control the thermal switch. Ang moisture sensing head consists of two heated metal resistant bulbs situated in the airflow and arranged so that the leading bulb screens the rear one in such a way that no moisture impinge upon. And when when the detector encounters moisture in the airflow, the shielded rear bulb remains dry and cool at slower rate than the wet leading bulb, and the moisture detector control is situated in the base of the unit. Then the areas that requiring protection are in the following is the compressor inlet guide 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 vanes, engine air intake slats, propeller, wastewater outlets, wing leading edges, fin leading edges, tailplane leading edges, cockpit windows, and pitot head, alpha probes. Then, so de-icing involves ice that is built up. Then anti-icing is used to prevent the formation of ice.